Good evening,
All right.
everyone.
So the live streaming for the session has now been started. The respective YouTube streaming link for the session today has also been added to the calendar event for today's session, so that it will be available to watch even later on. All right, let me first put down the agenda for today's session and what these sessions are going to be all about. So the first thing is going to be that all of these sessions are going to be based on the technical discussions. Uh, we will primarily be here in order to help you with the technical queries that you guys may have related to the course content and the course assignment, of course. In case you have a few, uh, you know, minor queries with respect to the grading, with respect to the exams, maybe those can be addressed, but it cannot be guaranteed that such type of queries will be, cleared or answered in these sessions, which are mainly organized for the technical discussion. But in case you want to get answers to such operational based queries, the best place is going to be to putting it on the discourse, or either you can write an email to the support team and they will be able to help you with better clarifications in that case. So I hope it is clear to all that these sessions will primarily be for the technical discussions, and we will try to avoid the operational queries in these sessions so that we can save the most of the time for the sessions for the technical discussion, so that we can utilize that time. Because the operational queries, I guess the session that was organized for this particular course only, I guess day before yesterday, many of the operational queries have already been answered, have already been clarified in that session. The grading pattern for the course has also been discussed in that particular session. So in case you guys have any queries with respect to that, I would suggest or recommend you to go and watch that session, because it is also available on the YouTube. So that would help you in order to get your queries clarified with respect to the grading pattern and probably some other operational queries that you may have with respect to the course. Okay, before moving forward, let me quickly see if there are any hands raised. Yes, Ravikant.
Good evening, sir.
Yes.
Basically, I want to know that how can I upload our worksheet for the assignment?
Okay, Ravikant, as I just mentioned that it will probably not be possible for all the instructors here in these sessions to help you with the operational related queries. Specifically me, I am probably not aware of all the operational aspects with respect to this course. So one suggestion would be to either go through the previous session that was organized, or you can put it on the discourse. That would be a better place for you to get your answer.
Okay, thank you, sir.
Yeah. So once again, I would like to mention that let's try to keep the discussion limited to the technical things, and please try to get your operational queries clarified outside these sessions. In case I will have answers to your queries, I would be very happy to help you with those. But as I just mentioned, that I will probably not be aware of most of the operational aspects of this course. So I will primarily be here for discussing the technical doubts that you guys may have with respect to the course content. Is this clear to everyone?
Yes, sir.
All right. Thank you. Your cooperation in these sessions will greatly be appreciated. All right. So as I mentioned, that the last session that was organized for this particular course day before yesterday was, it primarily went for operational query discussion and probably discussing the grading pattern for the course. So in today's session, the very first thing that I would like to do, here today is just to introduce you to the course, what the course is all about, what is going to be the syllabus, what all things we will be covering as part of this course. As many of you might have come with some expectations of what this course is going to be all about, what all different things, what all complex concepts that you will be learning going forward in this journey of 12 weeks in this course. So I will try to give you a small overview of what this course is going to be. There will be concepts that I will probably mention on the sheet or on some draft, which you guys will probably not be aware about. But you don't need to worry about that, because since this is just going to be a top level overview of what all concepts this course is going to be covering. In case you don't know about that thing right now, that's perfectly fine. No need to worry. Whenever we will reach to that particular week or that particular content, whenever we will be covering that, of course you will get to know about that. But today I just want to set an agenda for what all things we will be exploring, we will be learning as part of this C programming course. Is this clear to all?
Yes, sir.
Yes, sir.
Doubt.
Tell me.
Sir, this class is for qualified students or term students, like foundation.
This is for both.
Okay.
Both students are eligible and both can come and attend these classes.
Okay, okay, sir.
Sir,
All right. Yes, please.
sir, I have a doubt regarding the installation of Turbo C, or should we get it through WSL or Linux for the
I
dev?
don't think you need a Linux operating system in order to get started with Turbo. But maybe what I would suggest for the initial days is maybe try with an online IDE. So there is a very famous IDE available for running your programs online, which is REPL.it or REPL8.com. Now it has been called as REPL8.com. So maybe you can just create an account on REPL8.com and it will allow you to run your programs in several other languages as well. Not only C, it supports many other languages too.
Okay.
And probably in these sessions as well, I will be sometimes running my program on such online IDs too.
Okay, sir.
Of course, means if you want to have a dedicated compiler installed in your machine, that is really good thing. But probably for the initial weeks, in case you are suffering or you are struggling to get an installation done in your local machine, I would suggest to use an online IDE first, so that initially you can get comfortable with a little bit of the syntax of the language. All right, so please allow me to share my screen, and then I'll open up Paint or a draft screen so that I can tell you about the syllabus of this course. So please let me know as and when my screen becomes visible to you guys.
No, your screen is not visible.
Yeah, I'm just sharing it. It should get visible in next couple of seconds.
Yes, sir, now it's visible.
Yes, sir, now it's visible.
Yes.
Okay.
Sir, it's not visible.
I think it should be visible right now. Is it visible to all?
Yes, sir.
Yes,
Yeah, visual.
So,
Yes.
my screen is
Clear,
visible.
sir. All clear.
Okay, fine. Okay. Fine. So I hope that my paint screen is now visible to all.
Yes, sir.
Okay, great.
Yes, sir.
So as you know,
Yes, sir. Visible.
thank you. So as you all know that uh, this course is all about C programming. So let us first talk about what actually programming is. So the bottom line is, or if I talk about the most simplest definition that one could ever give in order to explain what actually programming is, it is simply a mechanism for us to instruct computer in order to get something done. That means we are trying to give some instructions to the computer in order to solve a problem, in order to get a specific task done. This is what writing programs is all about. Because ultimately, why are you writing programs? You are writing programs so that you can build softwares. You are writing programs so that you can build applications. And what is the purpose of using those or creating those applications at the end of the day? The end of the day is you want to get something done. Right? You can think of so many examples that are available around you. You can probably talk about food ordering apps. You can probably talk about uh, cab booking apps. You can think about any type of software that you use in your regular life, be it calculator or be it any other complex software that you can think of. All of these are actually built with the help of some programming language and ultimately programming. And what are they doing? What are they serving at the end of the day? They are serving the users. They are getting a specific task done for the user. They are making something easy for the user. So the simplest definition for programming is in order to get something done from the computer or to instruct computer to get something done, to get a task done. This is what the programming is all about. Now, when it comes to writing the actual softwares, the actual applications, there is a choice, of course, that lies with the programmer, that which programming language one wants to work with. So there are several programming languages available in the market these days. There is C, there is C++, there is Python, there is JavaScript. There are many other languages. Right? So what makes one language different from the other is going to be its features. If you talk about the C programming, this is one of the oldest programming languages that you probably know by date. If you talk about C, C++, Java, JavaScript, all these programming languages, C is the oldest one. And if you talk about C++, C++ is actually an enhanced version of C. You basically take C language, you add a few concepts, you add the concept of oops, that language actually becomes C++, almost like that. Of course, it's not the exactly same, but yeah, just telling you that CPP is just an extension of C language itself. So what I'm trying to explain you here is that C is one of the oldest programming languages that you probably know by this date. All right. So the first 2 weeks of this particular course, we will actually try to learn something about the computers. Since we assume that many of you might be coming from an entirely non-technical background, and in that case, it becomes essential for you to know that how does a computer system actually works. Many of you might be coming from the non-technical background, but might have some basic knowledge about computers. You might have worked with some basic applications, some basic softwares, be it Word, be it Excel, or you probably know, or you probably do some browsing. You probably use Gmail, etc., for your professional or for personal works. Of course, these things can happen. But the first 2 weeks will actually try to introduce you to the basic world of computer, what a computer is, what are the different components of a computer system. This is what the week 1 is going to be focusing about. Week 1 is entirely going to be about the introduction to computer system and its component. And its components. Now, components means it could be physical, it could be, you can say some virtual things. For example, the memory that we are talking about. There are some internal softwares that a computer makes use of. So all of these things are going to come in the virtual part. So in this week itself, you will probably be learning about the memory, the RAM, even the virtual memory that the computer makes use of. How does the computer get something actually done? How does the computer perform the calculations? Right? Because even if you're writing a software, the very, I would say the baseline of writing a software is actually going to be performing some arithmetic calculations. And the best example for this is going to be the calculator. Because if you want to build calculator, of course, you should be knowing that how to do arithmetic calculations. That is what the calculator is built for performing the arithmetic calculations. So week 1 is going to be telling you about what actually a computer system is, what all are its components, and how do they interact with each other internally. Right? One of the major component of a computer system is going to be a CPU, right? The central processing unit that you might have also heard before. And the CPU will probably consist of multiple other components that will be discussed as part of this week itself. All right. So week 1 is going to be all about theory. we will not be learning or touching programming at least as part of the week 1, because it's essential, as I told you before, that we assume or we expect that many of the students coming here in this course are coming from the non-technical background. So it's important for us to start the things right from the scratch, right? So that everyone can keep up with the pace. Now, after working with all of these things, once we have given you a fair idea about what a computer system is, what all are the components of a computer system, how does the CPU work, how does the internal things communicate with each other, the week 2, when we'll move to week 2, even the week 2 will probably not discuss about anything related to programming. Here we will be talking about the number representation mostly. The number representation and the encoding that a computer system makes use of. So you might be thinking what this number representation, what this encoding actually is. So have you ever thought that whenever you are typing something on your computer, let's say if I open a new tab and I'm typing something, say ABC here, right? So what I'm doing is I am typing ABC in my keyboard, the keyboard which is attached to my computer system. Now, when I am typing A, how is the computer getting know that I want to type A, on this particular screen? And one thing that you need to observe here is, as soon as I type, it automatically gets reflected within milliseconds in front of your computer screen. So whatever processing that is happening behind the scenes is so fast that human eyes can't even observe that time difference. So ultimately, you have to understand that the computer does not understand A, because you might have also heard this even before, that all a computer can understand is, can someone guess what all a computer can understand?
Zeros and ones.
It's either 0 or
Zeros and 1.
0
this
and
is
1.
all a computer can understand, right? Only these two things on a very I would say base level. Now, if a computer can only understand 0 and 1, how is the computer able to understand when I'm trying to type A, when I'm trying to type a digit, when I'm trying to type some other special symbol, when I'm trying to type some space characters, etc., any other special character? So this is the thing that you will get to learn with the help of this number representation that will be introduced as part of week 2, and the encoding, right, which of course works behind the scenes and actually converts whatever input the user intends to give into the respective code words that a computer can understand or a computer can interpret, right? So whatever input that I'm trying to provide to the computer, it is actually trying to convert it into its native language. Native language is, it is trying to convert that into a code of, or into a sequence of, or into a combination of zeros and ones. And once it understands that, it is trying to give me a relevant output to that. So all this thing is happening behind the scenes. And again, I would like to mention that it is happening so fast that it is not even possible for the human eyes to observe the time difference. It probably takes just a few clock cycles in order to perform all these things behind the scenes. So the first 2 weeks are probably going to be focusing on the theoretical aspects for you to understand programming better before we actually get the programming or writing the programs started. These are this is going to be the basic overview of what the first couple of weeks of this course is going to be covering. And once we are done with the first 2 weeks, then week 3 is going to be the place where you will officially be introduced with the programming world. Week 3 is going to be the place where we will be writing our first C program. So this is the intro to C programming. Is someone saying something? Yes, Abhishek, you want to say something? All right. Okay, so week 3 is going to be the week where we will officially introduce you to the C programming. This is going to be the week where you will be writing your first C program as part of this course. Of course, if you have some prior idea of writing C programs, you can even get started before. But in this particular course, you will be writing your first C program when we will reach week 3. And along with writing your C program, you will get to know some of the basic characteristics of C language, like the imperative nature of the language, like the structured nature of the programming language. Of course, you will be seeing these things as and when the course progresses, but you will get to learn some of the characteristics. Get to learn some of the characteristics of the programming language. And in addition to that, you will be learning the building blocks of any programming language here in week 3 itself. The building blocks are going to be the variables and the operators. Now, in case you don't know what actually variables and operators are, just want to give you a glimpse of what these two things are. Variables are going to be some containers which are going to be holding some data for you. Please understand that whenever you are writing a program, whenever you are writing a software or an application, you are trying to solve a problem. You are trying to get a task done. And in case you want to get a task done, the very first thing that is required is the user input. Because if the user is not going to interact with the software that you have written, what's the purpose of writing that software at all? So the very first thing is you require the user interaction. And when the user interacts with any software, what you get is you get some user input. Talking about a very basic application, calculator. When you use calculator, what you do is you provide some inputs. You provide some numbers as inputs. Let's say you want to get the addition of two numbers done. Those two numbers are, let's say, 212, and the other number is, let's say, 100. So these two numbers are actually going to act as the input to this particular software called calculator. So this is going to be the data that you will be working with, or your software is going to be working with. Now, when you are talking about data, then you also have to understand where that data will be stored. Because of course, if you want to work with that data, you will have to keep that data somewhere. The data cannot be directly transferred from the user's mind to your software, right? Of course, user will have to interact with the software. User will have to provide that data in some sense. Now, the question is, where are you going to hold that data? So in order to hold that data for you in your program or in your software, you are going to make use of a concept called variables. So variables are going to be the containers. They are going to be the actual boxes which will be holding the data that your program or your software is operating on, right, or working on. If you are building a simple enough application called calculator and you want to get the addition of two numbers done, then these two numbers that the user is going to enter, you will require variables in order to hold these two values so that you can get the addition for these two numbers. So this is where the variables will be required. And talking about operators, now operators are going to be having several categories. When I talk about operators, it is not said as only the arithmetic operators, or the operators scope is not restricted to the arithmetic operations only. There are many other types of operators that you will get to learn going forward into the course. Maybe a few of these operators I can mention right away. One, of course, arithmetic. Arithmetic are going to be the operators that you have used in your standard mathematics: plus, addition, subtraction, multiplication, and division, or you can say this type of division. These are all known as arithmetic operators. There are going to be some logical operators. Of course, I'm not mentioning any examples as of now because many of you probably not know about logical operators. So I don't want to confuse you at this point of time. There is a category that exists in this operator's world itself, which is known as logical operators. There are going to be assignment operators. There are going to be binary operators, and there are going to be many other operators. So these are some broad categories which are basically trying to group some similar type of operators into a single category. So operators is kind of the parent, and there are many categories to this category called operators. One of that is arithmetic. The other one can be logical, assignment, binary, and many more. So arithmetic operator, since you all know the standard mathematics, I have given you some examples. I am refraining from giving examples of some other types of operators because we have not started writing programs as of now. So don't want to confuse you at this point of time. Okay. Yes, Bhumika, do you have anything to ask?
Sir, can we call operator as a symbol?
Can you call operators as symbols, is it?
Yes, sir.
See, ultimately, when you will have to use these operators while writing programs, you will be using symbols for those operators only. Because if you want to perform addition, you won't say addition as part of your program. What you will be using is you will be using a symbol that associates that particular operator to its relevant operation. So for addition, you will use plus. Similarly, for subtraction, you will use minus. So while writing programs, you can say that you can replace operators with their relevant symbols. Yes.
Okay, sir.
All right. Yeah. So these are going to be some wide categories of operators, and all of these things will be introduced as part of week 3. So week 3 is going to be an introduction for you to the C programming world. You will get to know some of the characteristics of the programming language, and you will get to learn the building blocks of C programming, which will be variables and operators. Now, moving to the next week, that is going to be week 4. Week 4, we will try to dive into C programming, and we will get to learn some, complex yet interesting concepts. And those interesting concepts are going to include the usage of functions. And we will probably get to learn about recursions as well. And scopes. Scope and the lifetime. Scopes and the lifetimes. So these are the concepts that okay, this is probably not going to be the week 4. I think in week 4, what will be discussed is going to be the a slightly easier part than the functions and all. It is going to be the place where you will get to learn about the decision making. Decision making, you will get to learn about loops and iterations. Loops and iterations, and you will probably get to learn about some additional keywords that you use in conjunction with these concepts, that is loops and iterations. Few of those keywords are going to be break or continue. Since it's just a simple or a top level overview, I'm not deeping dive, I'm just giving you a top level overview so that you get to know what all things will be covered. Now, decision making is what? Decision making is going to be what should you do if something happens? What should you do if that? Okay. Real life example is going to be, let's say you have to write a software where a user is going to enter the marks in a particular subject, let's say out of 100. And depending upon the input that you get from the user, you have to find out the grade in that particular subject for that user. So ultimately, what you will be doing is you will be running some very, very basic decision making in your mind. Let's say if your score is greater than 90 or 90 itself, then you are going to get the S grade. If your score is greater than or equal to 80, you are going to get A grade. If your score is greater than or equals to 70, you are going to get B grade. If your score is greater than or equals to 60, you are going to get C grade, and so on. Means this is the very simple decision making that you will probably do in your mind itself in case someone lets you know their marks in a particular subject. So you will be able to easily interpret or find out what their respective grade is going to be in that particular subject. But now, if you have to create a program out of that, then how will you write instructions in order to tell the computer that if the marks are greater than this or less than this or in between this, then you have to compute the grade in this way. So in order to do all these decision making, in order to do all these ifs and else, like if your marks are greater than 90, then do this. If your marks are greater than 80, then do this. If your marks are not less than 80, something like that, right? So all of these fall under the category of decision making, where you make use of special expressions like if and else. Of course, we will get to know about if and else in more details when we will get to that particular week, but just giving you an overview that this is how you will be performing this taking part in to use such keywords like if and else in order to write some conditions, right? Because in real life we make a lot of decisions. Let's say I will be carrying an umbrella with me if it is raining outside, otherwise I will not. So this is actually a condition, right? Only if it rains, then I will be carrying an umbrella with me, otherwise I am not going to, right? If I get a bus on time, I will be able to reach my office or my school or my college on time, otherwise I won't be able to. So these are some real life examples of decisions that you make in your real life, and the similar things can also be applied in programming world, in the software world. And this is what will be taught as part of week 4, the decision making and the loops and iterations. So loops, just to tell you something about loops. So loops is a way to tell the computers to repeat a certain task multiple times. Let's say you want a computer to do something for you. Now, in case you want the computer to repeat that certain thing multiple times, let's say 10 times for you, then you have two options available. One thing is that you give the same instruction to the computer 10 different times, or the other option that is available with you is that you make use of loop. In loop, what you do is you simply tell the computer that I want you to do this task this number of times, and the computer will understand and it will repeat that particular task for you the number of times that you want the computer to do it. You don't have to give the same instruction to the computer 10 different times, so you are saving your effort. So that is what the concept of loops is going to be. Whenever you want a certain action to be repeated certain number of times, you make use of loops, so that you don't have to write the same code multiple times, or you don't have to give the same instruction to the computer multiple times.
Sir, I have a doubt.
Yeah, tell me.
Sir, you said that when we apply loops or any other function to a program, which a computer can understand, right?
Hmm.
My basic question is that how a computer sense that what I have to perform.
Okay, so for that you will have to give precise instruction. See, computer is just a machine. It can only do what we are going to ask a computer to do. Computer cannot do anything by itself. That is very, very clear. So whenever you want a computer to perform something for you, to get a task done for you, you have to make sure that you should be very, very precise with the instructions that you are going to give to the computer, right? So just to answer your question that how will the computer be able to interpret what we actually intend to do, we will have to write very specific instruction, very specific program, or very specific coding, so that computer can understand what needs to be done. Okay. For example, I was just trying to give an example of a software which is going to predict the grade of a student for a particular subject on getting the marks as input. So if you want to get the similar thing done from a computer, for example, you want a software which is just going to tell you about grade if you enter your marks as the input. So you will have to write very specific instructions where you will say that if marks, I am not writing the actual program here, I am just trying to write some pseudocode. Maybe let me just get this space cleared. So the type of instructions that I will be required to provide to the computer is going to be very precise. I will say that if marks are going to be greater than 90, or let's say greater than equals to 90, and the marks are less than or equals to 100. In that case, you will have to predict the grade to be, let's say, S or A, whatever you want to predict. And if this condition doesn't hold true, then you will have to provide some fallbacks as well, right? Because as I said, computer doesn't know anything. Computer cannot do anything by itself. You will have to
Like
give very precise instructions of what you intend to see from the computer. Similarly, in the next statement, you would say that if this condition doesn't hold true, then you will say that if the marks are greater than equals to 80 and the marks are also uh, less than 90, in that case you will have to say that the grade is going to be B. So you can understand that the level of uh, the level of clarity that you require in order to write any code. If I'm saying that you have to give very precise instructions, the first thing is you first have to gain that precise clarity. You
Sir, I
should be
have a
knowing exactly what needs to be done. Were I able to answer your question?
sir.
Uh,
Yeah, you please go, please.
Sir, my question is not that. I understand all this, but basically, a computer can understand a language of binary language, zeros
Yeah.
and ones. So,
Yes.
how can a computer interrupt with all this C programming, precise coding?
Okay. Understood.
Will there a software that converts all that coding in binary form and so that
Yeah,
the
you get it right.
CPU,
I think there is encoder circuit for it.
yeah, encoding or decoding?
Yes, you are getting it right. I think in the beginning of the session, I told you that whenever you are giving some input from your keyboard, let's say you are trying to type A. Now, again, A is something that is interpretable by the humans, but is not directly understood by computer. So what the computer does is computer converts A into some binary code internally, and then it gives you the relevant output. Similarly, if you're writing a program in any given programming language, no matter what, then what happens is there is a software. There is a software. That software is called either a compiler or an interpreter. Compiler or interpreter. The job of this software is to actually convert the code that you are writing into binary code so that the computer can understand that. So whatever program that you will be writing, you will have to pass that program through another software called compiler or interpreter, which is going to convert it into a language that computer can understand.
A.
All right, and that's how computer will be able to understand what actually needs to be done.
Okay. So, sir, this means that if I type A on my keyboard, the electronic signals through wires goes to the CPU, and
Yes.
in the CPU, the program counter uh, starts the program and finds the value of A and define the binary and tells the CPU to print this, and the CPU further sends the signals to the screen, and I can see the letter A.
Yeah, all these things are actually happening behind the scenes. Yes. So
Okay.
ultimately, you need some type of conversion because, as we have already discussed, this is something that a computer cannot directly understand. So you will have to provide the input to the computer in a language that it can understand. So in order to provide that input, you will need another software, and that software, specifically in terms of programming language, is either going to be a compiler or an interpreter.
Okay, sir. Thank you.
I think in the beginning of this session also someone was asking about the installation of Turbo C++. So it is
Uh,
also a software which is going to convert your program.
okay. Okay. Thank you, sir.
All right. So yeah, week 3 is going to be the week where you will get to learn about the loops, iterations, etc., and the decision making, the if and else. Now coming on to week 5. Week 5 is going to be the place where some
Sir,
interesting
I have a
things will
question.
happen. Yeah, tell me.
Sir, is this if and else statements is also can be understand as a parameters that is used to execute various programs?
Uh, I cannot understand that. Can you please elaborate it a bit? Parameters in what sense?
Actually, I have to say that. Actually, I wanted to say that is this if or else statement work as a parameters to execute different programs?
Yeah, you can say that, of course.
Yes, sir.
Because based on certain parameters, you are executing certain logic. If something happens, then okay, let's say if thing A happens, then you will do thing B. If thing C happens, you will do thing C. So all of these are some parameters based on what you are deciding what action needs to be taken.
Yes, sir. Thank you, sir.
Okay, so coming on to week 5 is going to be the place where you will get introduced to a very interesting concept in any given programming language, which is going to be the functions. Functions are considered very, very useful when you are actually writing some complex code, because it helps you in order to modularize your entire software into smaller logical modules. What you can do is you can wrap similar code or a code that belongs to a particular entity in a fixed module, and any code that is going to be operating on some other entity, you can actually separate that from the current module. Well, things might look complex as of now, but when we will get to that part, when we'll get to write some actual functions in C programming, then you will understand how useful the functions are going to be. But on a top level, functions are going to be a boon for modularity. Modularity plus the readability.
Sir, this means like if we do not use functions, the code will be much larger than the original one.
Yeah, that's true.
Okay.
Ultimately, the readability is going to be what is going to be affected.
Okay, sir.
And of course, the code length, as you mentioned, is going to be increased. Let's say you want to get the addition for two numbers done. Now, for a hypothetical scenario, or let's not take the addition example. Let's take something else. Okay, let's take this example itself, that you are required to write a simple program which takes the number as input and it tells you the grade as output. Now you are building a bigger software, you are building a complex software, and in that software, you are required to do this thing at multiple places. You are required to write this particular logic, that you have to accept an input and you have to provide the grade as the output. You have to do this particular thing at multiple places in the same software. Now, if you don't have the concept of functions available, what you will be required to do is you will be required to write the same code again and again. But if you have the functions available with you, you will write that code in a single place and you will wrap that entire code in a function. And wherever you want to execute that code, wherever you want to use that code, instead of writing the entire code, you will simply reference that particular function. So you are saving a lot of effort as well. Functions, along with functions, you will get to learn about scopes. Of course, functions come with scopes. We'll get to learn about the scopes of variables, the scopes of functions itself, and the lifetime as well. And along with functions, you will also get to learn about another concept, which is going to be recursion. Now, again, on a very top level, recursion can be defined as function calling itself. Function calling itself is a concept that is termed as recursion. Now, this is not a concept that is specific to C programming language. This is a concept that is used across the programming languages that exist in today's world. Okay, so recursion is going to be the concept where a function will be calling itself. Now, this function calling itself seems to be a technical term, might be something as technical jargon that you are probably able to interpret as, but it's okay. Remember that we will be discovering and exploring all these things whenever we will get to that certain area or the part in the course going forward. So this is going to be the week 5 overview. You will get introduced to functions. With the functions, you will get to know about recursions. How do you implement these techniques? And you will get to study about scopes and the lifetimes of variables as well as the functions. Now, after the week 5, we shall move to week 6, and week 6 will probably take you to the second phase of this course. So till week 5, you will say this is going to be the basic programming. Till week 5, it is going to be the basic programming, the basic C programming. From week 6 onwards, you can say you will start writing some advanced C programs, because the concepts that will get introduced starting from week 6 itself are going to be some advanced concepts that are not available in every other programming language. I'm repeating this thing again. From week 6 onwards, we will get to learn some special concepts that exist only in C programming and are not available in many other programming languages. I'm not saying that it is not available in any programming language, but it is not available in many other programming languages. So till week 5 is going to be the part which will probably be common for every other programming language that you will learn. That means the concepts that we will be learning till week 5, they are going to apply as it is in any other programming language too. Let's say you decide to learn Python afterwards, you decide to learn Java afterwards, then the concepts will actually gonna remain the same. Now, week 6 is going to be the place where the concept of pointers will be introduced. Now, if I try to give you a basic overview of what pointers is all about, though I have tried giving you a basic idea about variables. So variables are what? Variables are storage blocks. Storage blocks. Storage blocks means they are going to be holding some data. Now, if the storage blocks are holding some data for you, remember they are actually present somewhere in the physical memory, because if you're working with some data, that data must be present in your memory. Though you are able to access the data with the help of the storage blocks, with the help of variables in your program, but even if your variables are able to access that data, it means that particular data that you are operating on or you are working with is actually available somewhere in the physical memory. Physical memory means it is available in RAM. So when your program is under the execution, of course, the data has to come to RAM. So the data is actually present in your RAM, in your system's RAM. That means random access memory. So pointers are what? Pointers are going to be another blocks. Pointers are going to be another blocks which are going to be referring to the storage blocks. So what is happening here is you are creating a variable which is referencing to another variable is what a pointer is. Let me repeat this thing once again. Initially, we talked about the concept of variables. Variables are the storage blocks. That means if you want to work with some data, then you will have to hold that data somewhere in your program. So you will hold that data with the help of variables. And if you create a variable in order to reference another variable, this is known as pointer. So see, this storage block that I have created here, this is actually referring to some data. This variable is referring to some data. Now you are creating another variable which is referring to the storage block itself, and that storage block in turn is referring to that data. Of course, the concept might look complicated as of now, but you don't need to worry about that, as I have already mentioned that this is just a top level overview. Okay, and along with pointer, we will be doing some pointer arithmetic here. Pointer arithmetic means is, let's first talk about variables. Let's say you are working with two variables on a very hypothetical basis. Let's say those two variables are A and B, and you want to perform some arithmetic operations between these two variables. Let's say you just want to perform the addition. So if you want to perform addition, you will say A plus B, and you are going to get the result. Now, if you have to do the same operation with the help of a pointer, because what pointers are what? Pointers are one additional layer created on the storage blocks. Previously, you were directly accessing the data from the storage blocks. Now, what you have done is you have created one more layer over it. You have created another variable which is actually referencing to that particular storage block, which is in turn referencing to the data. So if you need to get this particular addition done with the help of pointers, then that concept, that phenomena is going to be known as pointer arithmetic. That means instead of doing A plus B, if you will do pointer A or pointer for A plus pointer for B, just writing it as P, pointer for B. If you do it this way, then this concept or this phenomena will be known as pointer arithmetic. Uh, are you able to get some sense of what pointers are? As I have already told you, you don't need to know
Yes, sir.
everything by now.
In,
Yes, sir.
in pointers, I have a doubt. Can I ask?
Yes, tell me.
Sir, you said that pointers are the reference storage box for a program. Like, if I make a program which tells to print something like hello world, print hello world, and I assign to it in a variable called a, variable a. In that variable, I stored whole program, the print program, and
Sorry. You are storing the entire program in a variable, is it?
no. That function like print hello world, only that.
Okay, you are just holding that character data or that string
Yes, sir.
data. Hello world.
Yes, sir.
Okay, fine.
Okay. So if I have to use that variable in any other program, like I am making a program of 1000 lines,
Mhm.
and I am using only the variable and on that place, so it can automatically assess this or not.
Yeah, go ahead, please.
Sir, I am telling that if I write a code of almost 500 lines,
Mhm.
and I don't want to repeatedly write print hello world, or print any other
Mhm.
sentence. So if I can make a variable for this, like print hello world, this will be refer to a variable called a, or character b, or c, or
Okay,
any
see,
other.
firstly, you have to understand that if you have to wrap your logic, then the functions are the better concept in order to do that. If you are talking about pointers, the better thing to work with pointers is going to be the data, not the actual logic. So if you
Okay.
are saying print hello world, now
Mhm.
it becomes a logic because now you are not only working with data, you are working with some logic. You want some context to be attached with that data because you are not now only concerned about hello world, you are also concerned about that the particular message hello world should also be printed somewhere, should also come as an output. Now you have attached a context with it. Now when you have attached a context, that means you are attaching some logic with it, and if you are attaching some logic with it, it well suits in a function, and it goes outside the boundary of a pointer because pointers are used to reference data blocks. Are you getting my point?
Yes, sir.
Hello world is a data, but if you are saying print hello world, it actually becomes a logic. It
Okay.
becomes a full-fledged instruction.
Sir, this means the uh, hello world can be referred as a pointer, but
Yes, hello
the
world can
print
be
hello
referred with the
world
help of
will
a
be
pointer.
not act as a pointer. It will be a logic.
Sorry, I missed your last sentence.
Sir, this means like the hello world will be a pointer, like referred as a pointer, but the print hello world will not be referred as a pointer. It will be a logic.
Yeah, yes, that's
Okay.
correct.
Okay.
And just to add some clarity to that, see, hello world that you are saying, now this is a data that is present somewhere in the memory. Somewhere
Yes.
in the memory. Now, pointer is actually referencing to that memory block,
Okay.
right?
Like
A pointer
somewhere
is
in the
only
RAM.
referencing to this memory block. That's all. This is all what a pointer is.
Okay.
Whereas
The
a
data
function,
blocks only.
yes, data blocks.
Okay, sir.
Whereas a function is used to wrap your logic in an entity so that it can be used multiple times without repeating the logic once again.
Okay. So, sir, if I have to make a variable for any of these, so what can be the variable? Like, if I have to make the uh, code, sorry, if I have to represent a proper like logic or data to a variable A, B, C, or any other word, so which two of those can be?
So you are saying if you have to associate your logic to a variable, is it?
Yes, sir. Like if I have to make a variable
Hmm.
out of two of these, so which can be the?
Okay, so see, this concept is not available in C programming language. This is available in programming languages like Python or JavaScript, where functions are also treated as first class citizens.
Okay.
So it is not possible in C that you can assign a function to a variable. No, this is not possible in C. So if you have written some logic inside a function, you will have to call that function as it is. You cannot assign that to a particular variable. Not
Like
possible in
radio
C.
dot begin.
Sorry.
Like radio dot begin as a function. So I have to call that function only.
Yes, that's correct.
Okay.
Not possible in C, but is possible in languages like JavaScript, where the functions are also treated as first class citizens.
Okay, sir. Okay.
Yes, Bhumika?
Sir, I don't understand the connection between, you said RAM,
Huh.
RAM and pointer. RAM is used to store data.
Yeah.
Then how can we relate it with pointer?
Okay. So firstly, let me tell you why did I bring this RAM here into the picture. So whenever you have written a program, let's say you have written a C program,
Okay.
and this C program can have a number of pointers. Let's say it can have a number of variables, and it can have some pointers, variables plus pointers that you have used in your C program. Now, whenever you will ask the operating system that you want to execute this C program, what will happen is the data, the program has to be actually loaded into RAM. RAM means random access memory, or the main
Yes,
memory
sir.
of your system.
Yes.
Random access memory. Okay, so your entire program will be loaded into this section that is called RAM. And whatever variables that you would have asked for in your C program, they will actually be allocated some space in the RAM. Let's say your RAM size is 16 GB or something, right? Then depending upon the
Okay.
size of variables that you have chosen in your program, some space will actually be allocated to variables. Let's say you have asked for 4 or 8 bytes. Let's say you have asked for 4 or 8 bytes for some variables that you have used in your C program. So this much of bytes out of the available memory, let's say 16 GB, of course, some will be used by some other processes too. You have asked for the allocation of 4 or 8 bytes for a specific variable that you are using in your program. Now, this space that you are seeing here, this space will actually be allocated from this memory called RAM only.
Okay.
The total available size for the RAM might be 16 GB, but out of that 16 GB, you will have to request some space where you are going to be keeping your data, because data has to be present in some physical memory location, and variables are just going to be keeping a track of what the actual value in that particular memory block is.
So, sir, what about the cache memory in RAM?
Cache memory is also physical memory.
Okay.
See, whenever you're talking about memory, it has to be physical. It has to be stored somewhere. Now, you might you can say that there is a concept of virtual memory as well in a computer system. But remember, even that
cloud.
virtual memory makes use of physical memory behind the scenes. Because if you have some memory, it is physically present somewhere. Even if you talk about cloud, you can say that I am storing something on the cloud.
The
I am
data
storing something, let's
centers.
say, on my Google Drive. Now, even the data that you are storing on Google Drive is actually physically present in some remote data center.
Yes, sir.
Right? So the memory has to exist in physical, though it might be not immediately accessible to you, for example, the cloud, but it is present at some other place, but definitely it is present.
Sir, this means like any program use RAM instead of ROM for fast access, right?
See, of course, whenever a program is under the execution, it has to come to the RAM only.
Okay.
It is
Sir,
executed in RAM only.
Okay.
See, whatever softwares that you are running in your computer system, they all are running in RAM. They are also, acquiring some space from your RAM if you are running a software. Let's say if I'm running this website, if I'm running this Meet, if I'm running this Brave browser here, all of these are consuming some memory from my RAM.
Okay.
So,
Sir,
sir,
it means the
pointer is
pointer
only
is storing
used
the
to.
address. Okay, one at a time, please. Maybe let us just finish with Bhumika first. Yes, Bhumika.
So, sir, pointer is only used to save memory.
Only used to?
Save a memory, store a
No, that
memory.
is. See, pointers are just the references to some memory blocks. Now, the actual use
Okay.
case of the pointers, okay, see, I can give you some examples, but I don't really want to complicate the things in the very first session. So, probably when the right time
Okay,
comes,
sir.
when we will move to that particular week, we will be able to clarify it in a more precise way. For
Okay,
now,
sir. Okay.
all I can tell you is that pointers are actually some references to the memory.
Okay, sir. Thank you.
Someone else was saying something. Sorry, Kevin, I'll come back to you.
Let's say it's like a path of it.
Come again, please.
Can we say it like a path of the memory?
Uh, See, we path of the memory, no, you cannot say that. See, when you are writing a program, the very first thing you need to understand it, you are actually interacting with the RAM, and the operating system will try to hide the internal implementation from you. The operating system will try to don't let you know that what is the actual memory space that you are making use of. But with the help of a programming language like C, you can actually get some addresses. You can get some memory addresses. But even those memory addresses are going to be the virtual addresses. Let's say if you have a RAM and you have 16 GB space available with RAM. So you will start creating indexes starting from 0, 1, 2, and you will end up creating so many indexes. So this index, this particular index that I'm talking about, this is actually the reference where a particular data will actually be stored at. Now the operating system will try to hide this data, will try to hide this actual reference from you, and instead it is going to provide you with some virtual reference. And it is going to create an internal map that, let's say, if it is telling you that the memory address you are referring to is 200, then internally it can create a map that if you are saying 200, that means it is my 100. Though your program will say that the data is stored at 200 memory location, but it is actually a virtual address which is mapped to some actual physical location in the memory. With the programs, you can only get a restricted access to the system. Right? All the operating system resources cannot be directly accessible with the help of a programming language, because the operating system also creates an abstraction in between. Are you getting
Sir,
it?
can I say something?
Yes, yes.
Sir, can you display the paint window?
Yeah, yes.
Uh, Sir, if I make a question, like simple question, M1 is 1, memory 1 is 1, and memory 2 is 2, and memory 3 is M1 plus M2.
Okay.
Sir, this means, like what I understand, like memory 1 has a value called 1, which
True.
can be referred as a pointer, right?
Okay. See,
Like
at
I
this point of
can
time, I would agree with you, and I would say yes. If you're treating it as a reference, I would say yes, M1 can be called as a pointer reference.
pointer reference,
But
like a
technically, see, I would not say it is technically correct, but since this is just the very beginning of this course, I would say you are logically correct.
no, no, sir. Like I am saying that if I assume that in the memory there is a location called M1 which have a
Mhm.
data called 1. So the
Okay.
data 1 can be referred as a pointer, like as a logic only, not technically, like as a like understanding. And the in the same memory, another memory called M2 has a data called 2. This 2 can also be referred as a pointer.
Uh, okay. See, I would rather try to decouple the concept of data with the pointers. See, pointer is a way for you to provide a reference to some data.
Okay.
Right. Talking about the actual implementation, just like I mentioned, let's say if you are creating a variable A, let's say you create a variable A, then
Okay.
some memory space will be allocated for this variable A. Let's say the memory address, I am just assuming it is 100, and the value that you're storing here, let's say, is 23.
Okay.
Okay. Now, what you can do is you can create a pointer. Now, you create a point. Now, pointer is actually going to be a variable only. A pointer will be created as a variable only, and it will also require some memory. Since it is a variable, it will also require some memory, and let's say it is stored at location 145. But what this pointer is holding, or the value that this pointer is holding, is actually the memory address of the value that it is referencing. So
Okay.
the value of the pointer is actually 100 because it is referencing to some memory location 100. And with the help of this memory location that you are seeing here, that is this 100, you can get access to the data that is stored here.
So, sir, why we need pointers? Like,
You need,
why we can't use variable directly?
that's a good question. But when you are using pointers, you are getting the flexibility to work with the low level architecture as well. You get the flexibility to work with the memory.
Okay, these variables A will be in the program, but
Yes,
the in the actual memory, there will be a pointer which points the location of a variable in that program using a
that's true.
program counter or
That's true. At many a times, a situation will come where you don't have the access to this a variable directly in your program, but
okay,
if you have the pointer to that memory
pointer.
address available, you can still access that.
Okay, the pointer will uh, set the computer. Sorry, set बोल दिया मैंने. The pointer will tell the CPU to access a variable on that particular location in the program.
That's true.
Okay, now I
Because
understand.
many times, as I told you, that variables, you might not have the direct access to the variables, but if you
Mhm.
still have the access to the pointers, then you can still access the data that is present at that particular
Okay,
memory
sir.
location.
Okay, okay. Like it's point. That's why it called a pointer. It's
Yeah.
point. That
So
there
maybe
it is.
more technical clarifications. See, right now even I am refraining from going into too much technical discussions because there are many other people who are probably clueless that what discussion is actually taking place here. So
Okay.
that's why I want to avoid such deep discussions at this point of time because we have just started. We have not even written a first C program so far.
Okay.
Fine. So week 6 is going to be the place where, as I told you, that week till week
Hello,
5,
sir.
the concepts that we will be studying in this course. Sorry, let me just complete this. Till week 5, we will be studying concepts that are probably common across the programming languages. But from week 6 onwards, of course, some complicated things, some complex things will start. But these are going to be some additional features that C language comes with and are not available in every programming language out there. Yes, please tell me.
Sir, actually, RAM is a high-speed memory, and register is also a high-speed memory.
Yeah.
But how can we distinguish between them, and what is the differentiate between them?
See, it's just a matter of who is going to give you the fast access. If you talk about registers, ultimately you have to understand who is trying to access the data. CPU is trying to access the data, right? And anything which is closest to the CPU is going to give you the fastest access. So registers are closest to the CPU, and that is why if you have some data stored in the registers, they are immediately accessible to the CPU. If you talk about RAM, RAM is also a fastly accessible medium. But if you compare between registers and RAM, then registers are more closer to CPU, and that's why they are immediately accessible, and that's why they are a little bit more faster than RAM.
So, sir, the program is using RAM. So this means the actual registers are using RAM for fast access
See,
for
if
the CPU.
you have some data stored in the registers, then
Okay.
that access to the data or the operations on that data, they become a little bit faster. If
With using RAM.
Yeah, if compared with RAM.
Okay.
So going forward, we will get to know about storage classes in C, and you will see that C actually provides you a mechanism for storing your data in registers, in actual CPU registers if possible. But yeah, all of these things will come going forward.
Okay, sir.
Now, coming on to the next week, which is going to be week 7. Now, week 7, here, we will try to get into the data structure world. So week 7 is going to be the place where the data structures are going to be introduced. And if you're talking about data structures, then the very first thing that will probably come into the minds of many which have some prior experience to the programming, it is going to be the arrays. The arrays and the strings. Now, again, since we have discussed a little bit about variables, and I am assuming that you might have gotten some idea that what variables or what purpose the variables will be used for. Variables will be used for in order to hold some data that your program is going to be operating with. But the limitation of variable is that it can only hold one value at a time. Let's say you wanted to get the marks of a student as input and you wanted to provide the grade of that student as output, then you can only take one input or one number as input in a single variable. If you want to accept multiple marks, let's say if you want to accept marks for multiple subjects or for multiple students, then you will have to create multiple variables for that. And whenever you are creating multiple variables, of course, the program length, the program readability is affected. Because if you have to work with many variables in a single program, sometimes it becomes difficult to understand that which variable is being used for what purpose, or which variable is being used for storing or holding what data. Now, this problem is actually solved with the help of a concept called arrays. What does array do is, array provides you the flexibility to store multiple values in the same variable. For now, I was telling you that one variable, it can only hold only one value. Let's say if you have a variable called a, then it can only hold 10 or 20 or 30 or 100 or whatever you want to store. If you want to get the marks of another subject or another student, you will have to create another variable for that. But if you use the concept of arrays, what you can do is you can work with one variable, but that single variable will get you the access of many values. Of course, I am not writing the actual syntax. As I have already told you, the syntax will be something that we will study, we will write when we will get to that actual bit. For now, I am just trying to explain you the concept. The concept is that with the help of a single variable, you can only hold one value. But if you bring the concepts of array into the picture, you can actually hold multiple values in a single variable as well. And the string, this string is also a type of an array only. It's just a matter of data type. So so far I have only taken examples for number type inputs or number type values 10, 20, 30. Of course, it is entirely possible that you would want to work with values that are not numbers. Let's say you want to work with names, you want to work with addresses, you want to work with some data that involves the use of characters. In that case, the numbers will not come handy. So these things are actually differentiated on the basis of data types. Now, C programming comes with a primitive number of primitive data types, and those primitive data types are integer, character, float, double. There are many more, but probably for this course or probably for writing, even medium level complex programs, you will be sufficient or you will be okay with using these four data types only. Almost all the problems can be solved with the help of these four data types. Of course, there are many other data types available as well, but you will only need them when you want to perform very specific or advanced type of computations. Okay, so array is just a concept which is going to let you store multiple values in a single variable, which was not possible if you don't bring the concept of arrays into the picture. So this is what arrays are all about. Are you getting my point?
Yes, sir.
Alright. Then going to the next
Yes,
week.
sir.
In week 7, we will be studying about arrays, strings, and a few functions. There will be a library as well that will be introduced as part of this week, but I'm skipping that discussion because that will probably require us to discuss a little bit of more technical aspects, which I'm avoiding right now. Moving on to week 8. Week 8, again, we will continue exploring some other data structures. In week 7, we explored a new data structure called array. And one another form of array was itself string. Now in week 8, we will be exploring few more data structures that are available in C. It is going to be structures, unions, and enums. There is going to be a keyword called type def, but okay, maybe let me avoid that right now. Let's first talk about data structures. So array was giving you the access in which you can store multiple values in the same variable. So the arrays was saying, the concept of arrays allowed you to store many values in a single variable. But the disadvantage of array here is that all the values that you're working with, that means all the values or these many values, they have to be homogeneous. Homogeneous means they have to have the same data type, the exact same data type. So again, coming back to the same example, marks. If you want to accept the marks of students, then of course arrays might be sufficient for you. But if you have a requirement where you want to work with multiple values, but the nature or the data type of those multiple values is not homogeneous or is not the same. A very typical example for that is going to be a student management system, where so far we were only working with marks. Now it's time to work with some other properties or other characteristics of a student as well. Now a student can have a number of characteristics that can include the student ID, the student name, the student parent's name, the student address, the student contact number. There can be many other things which you can think of, which can act as characteristics of a student. Now, as you all know, that address or the name or the parent's name, they all are the types of values which cannot be fulfilled with the help of a data type which is number in nature, because the name is going to include alphabets, which is not possible to store with the help of numeric values. And if you have a requirement where you want to work with multiple values with the same variable, but all the values are actually heterogeneous, or you can say they all belong to different data types, in that case, you will require the concept of structures. So the structure is the same thing, just like arrays, one variable, multiple values, or you can say many values, and different data types. In arrays, the data type was supposed to be the same, but here, even the different data types are supported. Right? This is what the structures are all about. Coming on to unions. Unions are actually used for optimization purposes. Now, there can be situations that you are writing a program and you are working with many values. You are working with different types of values, let's say. You are working with, let's say, name, you are working with numbers, you are working with even some other different data type that exist in C programming. But a use case is that you have to save your memory, because if you're working with different data types, of course, you will have to ask for memory allocation for each and every data type that you are working with, or each and every value or variable that you are working with. But in case you are being asked to optimize the memory resources for your program, let's say you were using an integer variable, you were using a string variable, you were using some other type of variable, you are being said that we don't have so many memory resources available. So now you are required to cut down the requirement of the memory resources to a lower limit. In that case, unions will actually come handy. But the condition is that with the help of unions, you can work with one variable, many values, different data types, but a condition that only one value will be used at a time. One value at a time. So ultimately, what you are saying is you are creating a single variable and you are holding all sort of different types of data in that single variable. That single variable is holding, let's say, the name of the student. The single variable is holding the address of the student. The single variable is holding the roll number of the student. The single variable is holding the mobile number. The single variable is holding the marks of the student. A single variable is holding all these types of values. But how is it possible? This is only possible when you want to work with one value at a time, at a very given instant. Let's say at a very given instant, I am only interested in knowing the marks of a student. At some other instant, I am only interested in knowing the address of the student. If this is what suits your scenario, then you can go with unions. Otherwise, you cannot. Of course, unions are providing you some memory level optimization, but it is coming at a cost. The cost is that you cannot access different values at the same given instant. You can only use one value at a very given instant. So if you want to work with multiple values, either you go with structures or you create multiple variables for that. But it will come in handy when you don't need to access all the values at the very given instant. So that is where the unions will come handy to you. Coming on to enums, enums are entirely used for code readability. They are used for enhancing the code readability, and it is actually a very, very, I would say, interesting concept as well as a useful feature. This is also supported, across programming languages. This is not something that only comes with C. Even many other programming languages provide you the access of using enums, because it is a mechanism for you that is going to enhance the code readability of the software that you will be writing. So this is what week 8 is going to be covering. Week 7 and week 8 are going to be introducing new data structures. Week 7 was all about arrays and strings. Well, all about arrays only, because strings are also some special types of arrays. And week 8 is the place where you will get introduced to structures, unions, enums. They all are the different data types. Are you getting it?
Yes, sir.
Okay, great.
Sir, I have a doubt.
Yeah, tell me.
Sir, what is the actual difference between a structure and union?
The structure and union difference is, if you create a structure and whatever different types of values that you want to work with, each of that value will require the memory allocation in the RAM. Whereas in union, it is not true. It is only going to require the space for the variable with the maximum size. Let's say I'm just assuming right now you don't know about anything about say data types, but I am saying that there is a data type called A, there is a data type called B, there is a data type called C. A requires 4 bytes in the memory, B requires 8 bytes in the memory, and C requires 6 bytes. Okay, I'm just assuming.
Okay.
Now you have created a structure which is making use of A as well as B as well as C. And you have created a union with the help of which you are also working with A, B, and C. Now, for sure, the structure will definitely consume 4 plus 8 plus 6. 8 plus 4 plus 12, 12 plus 6 is 18. It will definitely consume at least, I am saying at least here, at least 18 bytes in the memory. But if you are working with union, then it will only consume the biggest size out of these three variables, which is 8 bytes. So ultimately, you have saved 10 bytes here if you are using
Yes.
union. So this is the difference.
Okay.
But remember, there is a very specific use case for unions. The condition is that you should not be using all the values at the very given same instant. If you want to work with one value at a time, then you can work with unions.
Yes, sir. Get it.
So where does the other values go, sir?
In the same memory location. Same. So this is what the entire purpose of using union is. It is going to create a single memory chunk in the RAM, single. And all different types of memory have to be written in this particular memory chunk. Coming on to week 9, the next week, I think week 9 is going to be about dynamic memory allocation. Dynamic memory allocation. Now, what is dynamic memory allocation? Try to understand it. So there are basically two types of memory allocation. One is static memory allocation, one is dynamic memory allocation. Static memory allocation is where you are asking for certain amount of memory resources to be allocated as and when your program starts executing. Let's say you wanted to work with or create a calculator application. So all you wanted was just two numbers. I'm just assuming. All you wanted was just two numbers. So you created two variables in your program, and whenever your program will start execution, the memory for those two variables will be allocated in the memory. But what happens in case you require some extra memory when your program is actually under the execution? When your program is actually under the execution, you cannot create a memory, you cannot create a variable at runtime. Like you cannot modify your program at runtime. When your program is already under the execution, you cannot change your program. You have to have a provision in your program itself that if you require some additional memory, then there should be some provision through which you can even ask for some extra memory, because the memory that the program used to require, it has already been allocated even before the program started its execution. That was already done in static memory allocation. So as soon as your program started its execution, all the memory resources have been allocated. Now, if you require some additional memory when your program is already under the execution, that is where the dynamic memory allocation comes into the picture. That means you will be able to request for some additional memory resources even when your program is already in the running state. Now, of course, the questions that might be arising in your minds is that why should we ask for memory dynamically? Why can't we ask for the same memory, even before the start of the program execution in the static memory itself? So again, I would like to bring in the concept of optimization. There might be scenarios where you will not require that memory at all. There will be scenarios where you will be requiring that memory. So either you go with static memory where if you don't require that memory, then the memory resources that you had requested for before the start of the execution, those memory resources will be wasted. Right? Those will be wasted. Or the other way is you request for those additional memory resources at the runtime. That means when your program is already under the execution state, you are requesting for some additional memory resources. Of course, you are consuming more memory, but that is I would say occasional use case. You are not requiring it for every execution of the program. You are only requiring it for certain executions. So for sometimes for certain executions, you will actually be saving some memory if you are requesting for the memory dynamically. So that is why this concept exists in C programming, that you can even request for some additional memory resources when your program has already entered the execution state. Is it making sense?
Yeah.
Fine. Okay. going on to the next week. Next week is going to be, of course, 10. And week 10 is again one very interesting week where you will get to know about file handling. Does anyone know what file handling is?
Handle a file.
Okay. Does anyone know the use case? Why should one be working with files? Why do we actually need files in actual?
To store multiple files in one, or multiple programs in one.
Okay.
To get the
Let
input.
me tell you.
Organizing the for organizing the data and program.
Come again, please.
Manipulating data into a file.
To get the correct address of any program.
To give us an input data.
All right. So
To open and
Reuse of the data.
external data from.
Yeah, all of you are trying to give the answers, but let me try to give you the very exact answers. The exact purpose.
Sir,
We use
is
file
it how to
Read
store
or
the
write a file.
available data or info in a file with the help of a program?
Yeah, that's true. That is coming to the point. See, so far, I mean, till week 9, whatever programs that you will be writing, you will be working with some data, as I already told you in the very beginning of this session. If you're writing some programs, that means you are operating some data, operating on some data. And if you're operating on some data, you must be creating some variables as a part of your program. But you have to make sure, or you have to remember that as soon as your program finishes its execution, whatever data that you had that existed in the RAM, as soon as the program exits the execution phase, the data has been destroyed. The data that your program worked with, it will be destroyed. When you will run the new program again, it will be a fresh new execution. It will not have access to the previous data that your program might have worked with. Right? So the data that we are talking about here is not persistent in nature. That means as and when the first execution of the program gets over, or any execution of the program gets over, you lose the access to the data. But let's say you are writing a software for student management system where you have to feed the attendance for the student for every given day. But of course, it should not happen that if you open the software today, or let's say if you open the software tomorrow, you should lose the access to all the data that you have saved yesterday or day before. That should not happen. You have to store that data at a place which should even be available to you if you open that software, let's say tomorrow, day after, or even at a later point of time. So you basically require some space where your data can become persistent. That means even if you shut down your system, your data should not go away. If you're talking about data being stored in RAM, forget about shutting down your system and restarting it. Even if your program exits the execution phase and you again start it, your data is already lost. You have not even turned off your system, but your data is still lost because it was in RAM. As soon as your program exits the execution phase, the RAM data will be cleared for that particular program. So you need a place, or you need a space where you can store some data that will be available to you even if you restart your program, or even if you restart your computer. And file is the way to go. That means if you want to have some data, or if you want to work with some data that you want to make available to your program for a later point of time as well, then you will try to save that data in a file. And as you know, that once you create a file in your system, it does not get deleted until and unless you manually delete that file. So in order to give the persistence nature to your data, you work with file handling. You try to store the data in a file, and whenever needed, you try to read that data from the file. So you are trying to make your data persistent. Are you getting it?
Yes.
All right. So this is going to be the major objective of week 10. It will discuss all related concepts with respect to the file.
Sir, what I understand is you are saying that if I have to track my progress, I have to save somewhere.
Yeah, correct. Yes.
If I writing a program of 1000 lines and in one day I code 250 lines. So I have
See,
to save that 250 lines of code in some file.
see, that is a different thing. Means you are writing a software, of course, you are also writing those in files, but I'm talking about the use case of the software. See, when your program starts running, let's say you are done writing the entire software. Now you start that software, let's say you feed it some customer information in your software. Now, would you want that when you will close that software and open it again, would you want the customer information that you feed it before to be lost?
No.
Of course, you don't want that. So you will have to write specific logic in your program that whenever you get some input from the user, you store it at a place which is persistent in nature. So you basically create a data file with the help of a program. You are going to write code. You are going to write code which is going to create a file, which is going to create a file for you and write the data in that particular file. Write data. And
Okay.
once you write that data in a file, it becomes persistent. Whenever you will close your software or whenever you will reopen it or restart it, though the RAM has been cleared, but the file will still exist in your computer system in your secondary memory. So whenever you will restart that software, the software will read the data from the file now.
Okay, like
So that is what
store
I'm
a
talking
username and password on the website
Yeah,
for easy access.
yeah.
Okay. Like if you exit, so when you open again, so it doesn't require any username or password to fill again and again. It's
Means
saved
that
is
depends on
somewhere.
the software. See, that it depends on the specific software. Let's say even if you're requiring the user to enter the username and password once again, and you have thousands of users, so where are you storing the username and password of those 1,000 users?
Okay. Hmm.
Right. So that is where the file comes handy.
Like this thing will be in the data center of any other like search engine like Google data for.
Okay, so you have moved to, to the application even being deployed. See, if I'm writing a C program on my system, then the file that will be created is going to be on my system only.
Yes, sir.
Right. So if you are saying that you're running your program on cloud, then of course the file that you will create is going to be also created on the cloud only.
Okay.
That means it is not consuming the memory from your machine. The memory that is being consumed is from some cloud, from some other remote data center.
Okay.
But you have the access to that file. Your program will have the access to that file.
Hmm.
All right. So this is going to be file handling. In file handling, we will be working with text files. We will be working with binary files. We will be performing operations like read and write. So these are the things that we will be doing in week 10. And after that, we shall move to week 11. And okay, I think in week 11, we are trying to talk about some behind the scene talks. That means whenever a C program executes, how does it internally executes? What all processes run behind the scenes that are actually going to give you the output that you expect it to? So week 11 is probably going to talk about some behind the scenes thing. Whenever you try to execute a C program, which all softwares actually work, what do they actually do in order to execute that software? What level of optimization do they do? Means these things. So week 11 will be, you can say, theoretical concepts. Of course, you will be given some practical aspects to the terms being discussed as well. Let's say you will be required to execute a C program with the help of a command line interface, etc. So these things will be discussed as part of the week 11. This is kind of going to be the concluding week. In week 10, we will be discussing the concept of file handling, and in week 11 we will be discussing some of the theoretical aspects that we wanted you to understand, but after getting a fair idea about how the program works, or how the language works. Once you have gotten a fair idea about the language, then it becomes more interesting to understand how the behind the scenes things are working. If we introduce these things in the beginning, you will probably lose interest. You will probably find it difficult to understand. But once you have a fair idea about the language, the curiosity will come, like how the things are working behind the scenes. So this is what week 11 is going to cover, and week 12 content does not exist. So week 12 is kind of going to be a refresher week where we will try to do the revision of whatever we would have done so far. So week 12 does not have any explicit content. Right. So this is a top level overview of what this course is actually going to offer. The programming will officially be introduced from the week 3 onwards. Till week 5, we will try to cover the common concepts that exist across the programming languages. And from week 6 onwards, we will start jumping into concepts that are specific to C, and that provides you some additional flexibility, which is probably not available in every other programming language out there.
Sir, can you give us a little bit of description about the examinations?
I think this has already been discussed in the previous session, so I would suggest you to watch the recording for the previous session. It is already available on YouTube.
Okay, sir. Thank you.
I think someone has raised hand. Yes, please. Mudassar.
Sir, can you share the link for that session that you?
Yeah, it will be available in your calendar only.
Okay.
Or just a minute, let me get you, or let me pull up the calendar. So this is the link to the previous session that happened. All right, Rahul, you have a question?
Sir, how will be attendance recorded?
Okay, I am not really sure about the attendance part of it. I'm really sorry for that.
Okay.
Okay, so from the technical point of view, these were the things that I wanted to discuss pretty much in today's session. I just wanted to give you a top level overview of what all concepts will be covered as part of this C programming course, as you guys might have also come with some expectations, like you will also get to learn some new things with respect to this particular programming language. So hopefully you would have get some sufficient idea that what all things you will be learning going forward in a journey of 12 weeks from now. Okay, so since I'm pretty much done, okay. Vidyavrat, you have something to ask?
Sir, where do we need to submit handwritten assignments?
I'm sorry, but I'm not aware of this thing. Can you please put it on the discourse?
Okay.
You will probably be able to get an answer there. So as I mentioned in the beginning of this session also, these sessions will primarily focus on the technical discussions. In most of the cases, the instructors, or specifically me, I am probably not aware of many of the operational aspects of the course. So in order to get the clarifications for those, the best thing is going to be putting it on the discourse.
Okay.
Sir, can you give a little bit of idea about discourse? I don't know about discourse.
See, discourse is just a discussion forum. So it is a community of all the students uh, that have been enrolled as part of this particular program, and so it's an opportunity for you to interact with your fellow mates for this course. In case you have a question, you can post there, either one of the instructors or one from the support staff or your fellow learners will be able to assist you with your query there. So it is a community, it is a discussion forum where you can post your queries and someone from the community will be able to help you, guide you, or assist you there.
Sir, which ID will you will use for writing C program?
Which ID is it?
Yes.
Well, I would say it is something that is not really important because talking about me, I will keep switching IDs. Maybe for some sessions, I will probably use Repellate. For some sessions, I will probably use Programmer's ID. That doesn't matter. But yeah, in case you want a stable one, then I would suggest you to create an account on Repellate. It gives you the access to create as many C programs as you want, and you can see an entire history of what all programs you have written so far.
Okay, but Replit is now um, no more free. It's paid site now.
No, I don't think that. It should give you many features even in the free version. Have you tried creating an account there? Yeah, I know that it offers some premium features, but you don't need to use those premium features as long as you don't need them. The basic C programming you can do even with the free version.
Okay.
When will be the session for week 1 introduction will be conducted in Gmeet? I think it will happen a day after on Saturday. So I could have even done it in today's session if the time would have permitted. But since most of the time today has been utilized in discussing the entire course overview, so the next session is going to be covering things related to week 1 specifically. Okay, is there anything else that anyone would like to discuss? Okay, in case there is nothing, then it is probably a good time to end the session here. So thank you everyone for coming with us in the session here.
You, sir.
Thank you,
Sorry?
sir.
Thank you, sir. Yeah.
Thank you, sir.
Okay. All right.
Thank
Thank you once
you.
again and wish you all
Thank you,
a
sir.
good night and take care.
Thank you, sir.
Good night, sir.
Thank you, one
Thank you,
and all.
sir.
Thank you. Good night, sir.
Sir, Shivratri.
Thank you, sir.